Namaste. Welcome to our YouTube channel. So today we are going to discuss question number 1 from PSB 2024, where we are given with a system of linear equations where we have n unknowns and m equations, right? So this particular system of equations can also be written as Ax is equal to b, where A is a matrix with column vectors this and this, right? So we have total n column vectors and m row vectors, right? And this is the b1, b2, bm, or Ax is equal to b, which is the vector for which we are trying to find the solution x1, x2, xn. So we need to show that this system of linear equations in the unknowns x1, x2, xn has at most one solution. So either zero solution or one solution, not more than that. Some basic results that we are going to use. First one is product of any two matrices. Rank of such product will always be less than or equal to rank of any of those matrices. The second one is rank of A transpose is equal to rank of A, where A transpose is basically the matrix you get by interchanging the rows and columns of the matrix A. Third one is, say any n vectors you have, then those vectors are dependent if and only if for some non-zero Ci we have the sum is equal to 0. So if this sum is equal to 0 for at least one Ci not equal to 0, then we can say that x1, x2, xn are dependent. The fourth one is that the system of equations x is equal to b has a solution if and only if b belongs to the column space of A. So basically, by column space of A, we mean the vector space spanned by the columns of A. Or simply, B is a solution, or B has a solution for this particular system if and only if B can be written down as a linear combination of the columns of A. Okay. The last one is that rank of A is same as the number of independent rows in A, which is same as the number of independent columns in A. So these 5 are the basic results that we are going to use. So the first thing that we can say is rank of A is less than or equal to n. Why? Because we know that the number of columns in A is n, and rank of A is same as the number of independent columns in A by the last result that we just stated. So rank of A will also be less than or equal to n. Then we have rank of A is equal to rank of A transpose from the second result. Then rank of A transpose is greater than or equal to rank of A transpose into A from the first result, which is same as rank of I from the question itself. And rank of I is equal to n because I is the n cross n identity matrix. Now combining these two, we have rank of A is equal to n because from this we have rank of A less than or equal to n, and from this we have rank of A is greater than or equal to n. Alright. So what we can say that the number of independent columns in A is n. And we have a solution for the system if and only if this B belongs to the column space of A. Now we can have two cases. One, that B belongs to the column space of A, or it does not belong to the column space of A. Now if B belongs to the column space, what will happen? We can state that if this is the case, then there will be a unique solution for X. But why? We can have an argument for that. Suppose we have two solutions, two different solutions. Now when I say that there are two different solutions, it means that y and z both satisfies this, right? Then only this is a solution. And ay is equal to b can be written down like this, where a1, a2, an are my columns of A, and y1, y2, yn are the elements of Y. So same for az is equal to b. Now since this both sums are equal, we can say that this is equal to this. Now in the next step, we are taking this part on this side. We are getting this. And since y and z are not same, we have at least for one I, yi minus zi not equal to 0, which is basically a contradiction to the fact that ai's are independent. Right? We can refer back to the result that we stated for dependence. So since this is a contradiction, so our assumption was not true. We cannot have two different solutions. We must have only one solution. That is quite simple. We can really say from this that the possible number of solutions is 1 if it belongs to the column space, and it's 0 if B does not belong to the column space, which actually proves our result. Okay, so if this is clear and if you like this video, give some appreciation to the next person you meet. Hare Krishna.